In this class, now I am going to discuss with you hyperbolic trigonometric functions and whose inverse functions. Before going to the class, now I am requesting you to subscribe my channel and also like and share so that it reaches to many people. Now let us go to the class. So first, now I would like to explain you hyperbolic sine function. See the definition of hyperbolic sine function. F of x, f is a one function mapping from R to R is defined by f of x is equal to e power x minus e power minus x by 2 is known as hyperbolic sine function. You know, where e power x is an exponential function, so you are well known about this expansion. So e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on, where x belongs to real number. Okay, so you know, if you write x equal to 1 in which, so you will get, put x equal to 1 here, so and go for simplification. So here wherever x is there, there you write 1 and go for simplification. So you will get whose approximate value like this 2.718 and so on, 718 and 281 and so on. So this is non-terminating, non-repeating decimal, hence it is an irrational number. Okay, right. So this is the definition of hyperbolic sine function. It is also denoted by sine hx, which is equal to e power x minus e power minus x by 2. Now here how it is defining? From R to R. So here this represents a domain, this represents a range. Okay, so what is the domain of this sine function, sine hx? Domain is set of real numbers, and whereas range set of real numbers. Okay, right. Now let us go to whose graph. Now see here, x dash, y dash, this is an origin. So now we have defined sine hx like this: e power x minus e power minus x by 2. So now when you take domain value is 0, so respect to range will be how much? Let us take this range as y. When you take domain value 0, if you write 0 here, it is going to be 1, 1 minus 1, 0, 0 by something, 0. So that, okay, where do you get 0 comma 0? Origin. Okay, right. Now see, observe this, e power x, e power minus x can be written as 1 by e power x by 2. Okay, suppose, see here, when we write x equal to 0, we are getting range as 1. So where do we get that 0 comma 0? Domain is 0 and respect to range we are getting 0 here. Write 0, e power 0 becomes 1, e power minus 0 also 1, 1 minus 1, 0, 0 by something, 0. So your respect to range is also 0, 0 comma 0 we get like this. Okay, here we get. Right. Next, if you take any positive quantity like positive value in the domain, Okay, so you move from 0 to positive infinity. Okay, so then this part will become 0 because see, you are giving positive x values. So if you move from 0 origin to this side, so where do we reach? Positive infinity. If x value is very big value, so 1 by e means, it is an irrational whose approximate value 2.718 and whole power infinity. So 1 by very big value you will get. So which becomes 0. And what about here? E power infinity will be left. E power very big value becomes very big value by 2 also very big value. Means here you will get this kind of curve. If you keep on giving positive values, so this graph will go, it attains very big value. Okay, so move from origin to right side. If you keep on moving right side, so your range will go very big value, means it attains very infinitely very big value. So if you go to the graph, so it continuous. And similarly, see, if you assign x equal to negative value, so your graph will go like this. If you keep on moving left side of origin, so where do we reach? A negative infinity. So here if you assign negative infinity here, so this will become negative, and minus here negative infinity, and if you write here negative infinity by 2. Now e power negative infinity can be written as 1 by e power infinity minus of minus plus e power infinity by 2. So this part becomes 0 because 1 by very big value, which becomes 0. You know that. So here what is left? Minus very big value by 2 becomes very big value only, means infinitely many value. So it reaches negative infinity in the range. Okay, so where do we have negative infinity on this graph? On the y-axis, somewhere else. Okay, so this is the graph of sine hx. Okay, and I hope you have understood how I have drawn this graph. Okay, so first what did I do? I kept 0. So whose range became 0, that is this point. Next I assigned positive values. If you keep on assigning positive values for x, your range is also increases. How it is increases? Here I have explained you. So if it is given very big value, infinity, this part becomes infinity, this part becomes 0. Infinity by 2 becomes infinity. So your graph will go like that. Similarly, negative value, if you put x equal to negative infinity, it goes down. If you keep on giving negative x values for here, for this x, your range will become negative. So it is continuous graph in its entire domain, no break. Hence it is a bijective function in its domain. Okay, what is the domain of the sin hx? Set of real numbers. And where range? Set of real numbers. Okay, now observe the graph of sin hx in its domain. It is strictly increasing, no? So as we know, strictly increasing or strictly decreasing functions are always bijective functions. Bijective means which will be one function as well as onto function. Hence, this function can be invertible in its domain. Means inverse of that function is possible. Okay. Now let us go to whose inverse function. Okay, right. Now see students, f of x equal to, next what I am going to discuss with you, sin h inverse of x. Sin h inverse of x. So if you observe the graph, how do you get whose graph? See here, x, x dash, y, y dash. Now, basic sin hx function, okay, defined from R to R, whereas whose inverse function, sin h inverse of x, So, these two will be interchanged. Okay, so R to R only. R to R only. Here, range. Okay, when you take whose inverse, this range will be the domain for the inverse function. And here, this is the domain of sin hx. But when you go to whose inverse, this will become a range. Okay, so domain and a range of sin hx, and these two are domain and ranges of sin h inverse. Now go to the graph. Okay, so if you draw the graph of the sin h inverse of x, you will get like this. No confusion. Okay, sin hx, have you got? So like this you got, no? This is the graph of sin hx, and whose inverse is sin h inverse of x. So it comes like this. Okay, so both are non-periodic functions, because in its domain this graph is not repeating. Okay, strictly increasing. Both are strictly increasing. If a function is increases in its domain, and whose, if the inverse is possible, and whose inverse function is also increases. If the function is decreases, and whose inverse will be also decreases. Okay, so here both, this is the graph of sin h inverse of x, and this dotted curve represents graph of sin hx. I hope you have understood about this graphs of sin hx and sin h inverse of x. Okay, right. Now let us go to define sin h inverse of x. Right. Now for this, see what I am doing. Let us take this function as y. Now, so y, otherwise you can write here y. Let us take this function is equal to y. Now sin h inverse of x equal to y. When you take sin h inverse right side, now x is equal to sin hy you will get. Now x is equal to sin hy e power y minus e power minus y by 2. Okay, right. Now students, see here. What did I do here? I have taken sin h inverse of x as y. Next, this sin h inverse I shifted to right side so that it will come as sin hy. Now sin hy definition e power y minus e power minus y by 2. Now which is equal to e power y minus e power minus y. E power y will come by 2. Here nothing is there, means 1. Now x is equal to, when you take cross multiplication, e power y whole square minus 1 by this will come to the down, e power y. Okay students, so in the next step, observe me what I am going to do. See, when you take cross multiplication, e power y whole square minus 1, which is equal to, so 2x into e power y. In the next step, bring it to the left side. So what do you get? E power y whole square, when it comes to the left side, minus 2x e power y minus 1, which is equal to 0. Okay, right. Now, it is looking like a quadratic equation in terms of e power y. Am I right? E power y. Here e power y whole square minus 2x e power y minus 1 equal to 0. So observe that it is a one quadratic equation in terms of e power y. Now, solve this one with the help of that quadratic formula. Minus b plus or minus root of b square minus 4ac by 2a. But here, use that plus symbol only in the middle. Because e power y is a exponential function. It is always positive. e power x graph. So if you draw the graph of e power x, so you will get like this. It is very close to x-axis but never touches the x-axis. It will go like this and it intersects the y-axis at 0, 1. So what is that? F of x equal to e power x. This is what? Graph of e power x, where x is a real number. Okay students. So here whose domain is set of real numbers, whereas range is open interval of 0 to infinity. Okay, right. So that what do you comment on e power y? E power y is always positive. So here, okay, apply that quadratic formula. Use plus symbol in the middle, minus b. B means here e power y coefficient minus 2x plus root of b square. B square means minus 2x whole square, 4x square minus 4ac. Here e power y whole square coefficient 1. So 4a, c value minus 1. So here you will get 4 by, so 2a. A value 1. So this much you will get and go for simplification. E power y minus of minus plus and here root 4. Okay, inside of the square root 4 is there. Take that 4 common. While it is coming, it will come as 2. And again take 2 common and cancel with the denominator. So here, after cancelling, what is left here? 2 I took common from the numerator, I cancelled with the denominator. Here x left plus there root of x square plus 1. Okay, now e power x is equal to x plus root of x square plus 1 you got. When you transfer e to the right side, now y is equal to log of x plus root of x square plus 1 with base e. With the base e. Okay students, now you got y value. So y is nothing but what? In the beginning we took f of x is equal to sin h inverse of x equal to y, no? No, y this much you got. Log of e x plus root of x square plus 1. So this is sin h inverse of x value. Log of x plus root of x square plus 1 with base e. Right. So students, suppose if you want this function derivative, okay, so then what do? Find the derivative of this function f dash of x. So derivative of sin h inverse of x. Sin h inverse of x is defining like this, no? Find whose derivative. You know log x derivative 1 by x plus root x square plus 1. Is this x? No. Follow the chain rule. Derivative of x becomes 1. Root x derivative 1 by 2 root x. Now is this x? No. Follow the chain rule. 2x you will get. So 2 cancel. Now take cross multiplication. 1 by x plus root of x square plus 1. So now when you take cross multiplication, x square plus 1, so square root of x square plus 1 plus x by root of x square plus 1. Now these two will be get cancelled. Now what is left? 1 by root of x square plus 1. So this is the derivative of this sin h inverse of x. Okay. So you know the domain of sin h inverse of x is set of real numbers, whereas range also set of real numbers only. So here x can be any real. Okay. So in its domain it is continuous. Hence, so derivative is possible. Whose derivative is 1 by square root of x plus 1. Okay. Suppose if you would like to find integration of this function. Okay. Integration of 1 by root x square plus 1 dx. If it is given, you know, integration is nothing but antiderivative of a function or primitive of the given function or The simple way you can define like this. The reciprocal of differentiation is known as integration. This we have differentiated. You got this. Suppose when you find whose integration, you will get this. Okay? Derivative of this is 1 by root x square plus 1. When you find integration for this, you will get this. Sin h inverse of x. Otherwise, it can be written as log of x plus root of x square plus 1. Okay? So, sometimes, so here in the place of 1, so they will give you a square. Now, in the RHS also, see here, sin h inverse of here x by a. So, which is equal to log e x plus root of x square plus a square you will get. Instead of 1, if any other real number is given, so write like this, sin h inverse of x by a, and here 1 a square. Okay, remember this formulas which helps you while doing the differentiation and integration applications. Okay, so this is about hyperbolic sine function. Now let us go to the cosine function, hyperbolic cosine function. See, whose definition? F is a mapping from R to R to, so closed interval of 0 to infinity you will get. This cosine function will define an entire real number set, whereas range will come closed interval of 1 to infinity you will get. Okay, is defined by f of x is equal to cos hx is equal to e power x plus e power minus x by 2. So this is the basic definition of cos hx, e power x plus e power minus x by 2. Okay, right. Now let us observe whose graph. X dash, y dash. See, it is defined on the entire real number set. Suppose if you put domain value as 0, e power 0 becomes 1, e power minus 0 becomes 1, 1 plus 1 2, 2 by 2 1. So where do you get that 1 on the y axis? Here you will get 1. Hereafter, give negative real values and positive real values for x. If you write negative real values for x, suppose first give a positive real value. So if you write positive real value, what do you get? Positive real value like previous one, sine function, hyperbolic sine function. We have assigned positive real value for x now. So this becomes 0. This attains very big value. Okay, when you write, students, when you write positive x values for here, this approaches 0. If you keep on moving right side, so this part becomes 0, but this attains, okay, maximum value. But minimum already we identified. Okay, that minimum value occurs at x equal to 0, that is okay, 1. If you keep on giving positive values, so your graph will go like this. It will go up. Okay, right. Similarly, assign negative x values left side. If you assign negative x values here, if you keep on moving left side, you reaches a negative infinity now. So here negative infinity plus negative of negative infinity by 2. This becomes positive. Okay, so this becomes 0. Okay, students, what do you get? here e power minus infinity means 1 by e power infinity, this part becomes 0, and this became again e power infinity by 2, means as you know e power infinity is always positive by 2. Okay, means range will be for positive only. So here we are giving negative real numbers for x. Your graph is going like this, because along with the positive y axis only will come. Okay students, no confusion here. Move right side. Your range will be more than 1 only. It will go like this. Move left side. This is negative x values. But if you write negative x values, this becomes 0 and this becomes positive. You know e power infinity is positive by 2. So positive only will come, but that will be more than 1. Okay? So you get the graph like this. It will go right side, and when you give negative x values, it will go like this. But that minimum value in the range will be 1. Maximum value you cannot say. Okay? I hope you have understood the graph of this cos hx e power x plus e power minus x by 2. Okay? Now, what is the domain of this function? It is defined on the entire real number set. So that domain is set of real numbers. But whereas range is 1 to infinity. 1 is included. So that I kept here closed brackets. Okay? 1 to infinity. Right. Now, let us go to whose inverse function. Now, but okay, observe this summa, this previous function cos hx. So in its domain, okay, so that function is not bijective, because you got the graph like this. Like this you got. Okay, so here when you move from left to right in the negative x values, your graph decreases. When you assign positive x values, your graph increases. So that it is not bijective in its entire domain. Okay? So here you have to take this closed interval of 0 to students here this part too. In this part it is bijective, in this part it is bijective. But this part, closed interval of 0 to infinity, you have to treat it as principal domain for this cos hx. Okay? What is the domain of cos hx? Set of real numbers. But observe their graph. In the negative interval, graph is decreasing. In the positive interval, graph is increasing. But which domain you have to consider as a principal domain? Closed interval of 0 to infinity. Because in which that is strictly increasing, hence it is bijective. Hence it is bijective means inverse is possible. Okay now, right? You know the meaning of principal domain. Principal domain is a domain in which the function is bijective. Hence that function can be invertible. Invertible means inverse of that function is possible. Right. Okay? Alright. Now let us go to whose inverse function. Now whose inverse function will define like this. Cos h inverse of x. Okay? Tell me whose domain. Inverse function domain. So is a closed interval of 1 to infinity. Previously this was the range for the cos hx, but when you go to whose inverse, you know already many times I have discussed with you. So if f is a bijective function from a to b, then inverse is possible. Whose inverse function will map from b to a. F is a mapping from a to b. A is the domain, b is the range. If it is bijective, then f inverse will map from b to a. B will be the domain for f inverse. A will be the range for f inverse. But previously b was range for f of x. And a was domain. But here a became range, b became domain. Here also 1 to infinity. Closed interval of 1 to infinity is the domain of cos hx. and whereas range, okay, whereas range will be closed interval of 0 to infinity. So how this cos h inverse will map from closed interval of 1 to infinity to closed interval of 0 to infinity. Okay, I hope you have understood. Now let us go to the graph of cos h inverse of x. Now in this interval, draw whose graph? How do you get? See this, x dash, y dash. Now this is origin. So now domain values are beginning from 1 to infinity. Where do we get 1? Somewhere here. Okay. Now if you keep on giving x values from 1 to right side, okay, your range will go like this. Okay. Now range is beginning from 0 to infinity. So here this is 1 comma 0 point. Your range is 0, no? Students, actually this is a 1 on the x-axis. If you would like to represent this point, what you would write? 1 comma 0. When you put okay 1 now, x equal to 1, your respective range will be 0 you will get. Okay, in its inverse. Okay, so if you keep on giving x values more than 1, then your range will go like this, 0 to infinity. Range is beginning from 0 now here. Where you got this range became 0 whenever x is 1 in its inverse function, not in cos hx. Observe that. Okay, so this will be the graph for cos h inverse of x. Okay, see here, domain values are increasing, range is also increasing, because so you observed in the graph of cos hx in its principal domain that graph was strictly increases now, hence whose inverse function is also strictly increases. Okay, right. Now even this cos h inverse x also can be expressed in terms of logs. Okay, how do you get that cos h inverse of x in terms of log means? So you would have to consider this one is equal to y, same like sin h inverse of x. Okay, so okay students, now what do you do? Transfer this cos h to cos h inverse to the right side, so that what do you get? X is equal to cos h y. You know cos h y is nothing but e power y plus e power minus y by 2. Now again take cross multiplication, 2x which is equal to e power y plus 1 by e power y. Now here it is 1. Now take cross multiplication. Now 2x is equal to, yes, e power y whole square plus 1 by e power y. Now simplify this, e power y whole square. So that what do you get? 2x into e power y plus 1 equal to 0. Now it is a one quadratic equation in terms of e power y. Now e power y is equal to, okay students, it is a quadratic equation in terms of e power y. Solve it. So as you know, e power y is positive, so that in the quadratic formula in the middle you must consider plus only, minus b. So plus or minus root of b square. B square means 4x square minus 4ac. So minus 4 you will get by 2a2. Now again take 4 common and cancel with the denominator 2. When you take 4 common, root 4 value 2. Again 2 common from these two and cancel with the denominator. Finally you will get e power 5 y is equal to x plus root of x square minus 1. Okay students, right. Now when you transfer this e to the right side, so that you will get y is equal to log e of x plus root x square minus 1. Okay, right. Next, Okay, this is the definition of cos h inverse of x. Log of x plus root x square minus 1 with base e. Already we observed whose graph. Okay, the domain was beginning from 1 to infinity. When you write x equal to 1 here, 1 minus 1, 0. Log 1 with base e will come. Log 1 with base e is 0. Range is 0. 1 comma 0 no? As I said to you. So if you keep on giving x values more than 1, your graph will become strictly increases. Okay? So domain 1 to infinity. Whereas range close interval of 0 to infinity. Okay? Now let us go to whose differentiation. If you find whose differentiation f dash of x, what do you get? So log x derivative, here in the place of x, this expression is given. Log x, x plus root of x square minus 1. Is this x? No. Again do derivative of this. X derivative 1, root x derivative 1 by 2 root x. Okay. Now is this x? No. Again 2x. Now 2 cancel. Okay. Now 1 by x plus root of x square minus 1. Now take cross multiplication. Root x square minus 1 plus x by root x square minus 1. Now these will be cancel. Now what is left? 1 by root x square minus 1. So this is the derivative of cos h inverse of x. Okay. 1 by root x square minus 1. Suppose if you want to see whose integration, so integral of 1 by root x square minus 1 dx is equal to, so what do you write? Cos h inverse of x or a log of x plus root x square minus 1. Okay, suppose sometimes in the place of 1 they will write a. So 1 by root x square minus 1 dx, which is equal to here cos h inverse of x by a. Now which is equal to a log of x plus root of x square minus a square plus c you have to add. You know, okay, here a square. This is the integration of hyperbolic cosine function. Okay, now let us go to the hyperbolic tangent function. See, hyperbolic tangent function. See here, f of x is equal to, see here, f will map from R to open interval of -1 to 1 is defined by f of x is equal to e power x minus e power minus x by e power x plus e power minus x is called hyperbolic tangent function, that is denoted by tan hx, which is equal to e power x minus e power minus x by e power x plus e power minus x. So whose domain is set of real numbers, whereas range is -1 to 1 only will come. Why? Because take any real number for domain f of x. Okay, right here for x, you get numerator value is smaller than the denominator. Am I right? Take any x value, real number from the domain and write here for x and simplify. Your numerator will be smaller than denominator. Okay, so that is proper fraction. When you convert proper fraction into the decimals, so you will get, okay, like minus 1 to 1 only. Okay, you may get negative or positive. I will show you that. Okay, so we substitute x equal to positive real numbers and negative real numbers and x equal to 0. Then how whose graph will vary, I can show you here. Okay, right. Right, now see here, graph of tan hx. So here, let us take 1 on the y-axis here, minus 1 over here. Now if you put x equal to 0, e power 0 becomes 1, e power minus 0 also 1, 1 minus 1, 0, 0 by, here you will get here positive value, 1 plus 1, 2, 0 by 2 you will get. When you put x equal to 0, your respective range will be e power 0, 1 minus 1, 0, 0 by 2 becomes 0. That is this point. Hereafter, so what you people have to do? What do you people have to do? Tell me. So you have to give positive x values. So you move from origin to right side. So when you keep on giving positive x values from left to right, your x values are increasing. If you keep on moving, okay, positive infinity, this part becomes a 0. So this part becomes a 0. Okay, then what do you get here? What do you get? Same value, no? Same cancel. Do you want to say 1? No, because your exact x value you don't know. We are giving very big positive infinity value, but how much is that we don't know. Okay, this is also we cannot say exactly 0. It is approximately approaches to 0, means very close to 0. Okay, so that here this range will be smaller than 1 only, not exactly 1. If you keep on giving positive infinity, this is not exactly 0, approaches to 0, but by default we write is there 0. This one is also approximately 0, and same quantity will come. Don't cancel, don't say as 1. It is very close to 1. See, you get the graph like this. It goes like this. If you give negative values for x here, students, I think you have understood this. If you keep on moving right side, your graph increases like this, but never touches 1, because if you draw a horizontal line through the 1, that horizontal line never be the asymptote for this curve. What is asymptote? It is a tangent which touches the curvature in infinitely many distance. You can say it as asymptote, but not tangent. You know the clarity between the asymptote and tangent. Tangent means exactly point of touching, means point of contact we can recognize, but asymptote, it may touch us but we cannot recognize. So this x equal to 1 is the asymptote for this curve. So similarly, if you keep on giving negative values, so negative values means this becomes so if you substitute a negative infinity for x, e power minus infinity, so e power, this becomes positive infinity, e power negative infinity, e power positive infinity. So this becomes approaches to 0. So here what do you get? A value smaller than minus 1. Am I right? Smaller than minus 1, because here this part is going to approaches 0, this is approaches to 0 here. Minus by plus will be left, so that this quantity is negative. How much is that? Means smaller than minus 1. So it goes like this. But if you draw a horizontal line through this minus 1, through this plus 1, it should not touch us. The graph of tan hx will vary between minus 1 to 1. So like this, strictly increases. Strictly increases means, you know, it is bijective, hence whose inverse is possible. Okay, and also it is not periodic function. Okay, right. Can I erase it? Right. Now, okay students, so let us go to whose inverse. Okay, now tan h inverse of x. Now can you tell me the domain of tan h inverse of x? From where to where it will define? So minus 1 to 1 is the domain for tan h inverse of x, whereas range is set of real numbers. Okay, previously tan hx was defined, okay, from r to minus 1 to 1, but whereas for whose inverse you will get, this will be the domain and this will be the range. Now let us observe the graph of tan h inverse of x. Graph of tan h inverse of x. See, how do we get? See here. X dash, y dash. So domain minus 1 to 1. As I said to you, range set of real numbers. You get the graph like this. This is a graph of tan h inverse of x. If you draw vertical line through the minus 1, through the 1, that vertical lines never touches this tan h inverse of x curve, because those two will be asymptotes. Okay, so this is the graph of tan h inverse of x. It is also strictly increases. And observe here, till now what we have done? Okay, we have discussed three functions. Let me define this tan h inverse of x in terms of log. See, same like previous. F of x equal to, tell me students, tan h inverse of x is equal to, what do you write? Students, tell me. You have to consider this as y, same like previous functions. Now when you take tan hx right side, x equal to tan hy you will get. Now x equal to e power y minus e power minus y by e power y plus e power minus y. Right. Now which is equal to, if you simplify, e power y minus 1 by e power y by e power y plus 1 by e power y you will get. Okay. Right. Next, when you take cross multiplication, x equal to e power y whole square minus 1 by e power y whole by e power y whole square plus 1 by e power y. Now e power y cancel. Okay. Now let us take e power y is equal to some k. If you take this is k, then it will become x equal to k square minus 1 by k square plus 1. Now take cross multiplication. If you take cross multiplication, what do you get? Students, tell me. X into k square plus x. Now k square minus 1. Now bring this minus 1 to the left side, 1 plus x. Send it to the right side so that k square take common, 1 minus x. Now k square is equal to 1 plus x by 1 minus x. Now k is equal to, otherwise apply log on both sides. Apply log on both sides. Otherwise transfer square to the right side. K is equal to 1 plus x, 1 minus x whole power 1 by 2 you will get. But what is k? E power y. E power y. So k equal to e power y. Now which is equal to, right, what do we get here? 1 plus x by 1 minus x whole power 1 by 2. Right. So now take e to the right side. Here it is there in exponential form. When you convert it to the logarithmic form, y equal to log e of 1 plus x by 1 minus x whole power 1 by 2. Now bring 1 by 2 to this side. Now 1 by 2 of, students, what do you get here? Log of 1 plus x by 1 minus x. What is y? Tan h inverse of x. Tan h inverse of x, which is equal to 1 by 2 of log 1 plus x by 1 minus x. Okay students, I hope we have understood this derivation. Tan h inverse of x equal to 1 by 2 log of 1 plus x by 1 minus x. You know, okay, what is the domain of tan h inverse of x? Minus 1 to 1, whereas range is set of real numbers. Okay, now shall we go to whose differentiation? Now let us observe this differentiation. Now let it be f of x. Find f dash of x. Find the derivative of tan h inverse of x. What do you get? 1 by 2. Log x derivative 1 by 1 plus x by 1 minus x. Is this x? No. Follow the chain rule. You know, chain rule. It is looking like u by v. Now we keep aside. Do the derivative of u. 0 plus 1. Next 1 plus x and do the derivative of this. 0 minus 1 by 1 minus x whole square you will get. Now go for simplification. So when you simplify this, what do you get? This 1 minus x will go into the numerator. 1 minus x by 2 into 1 plus x. And here 1 minus x. Okay. When you open this bracket, minus into minus plus. 1 plus x by 1 minus x whole square. 1 minus x into 1 minus x. Now 1 minus x cancel. Now these two are cancelled. 1 plus 1, 2. 2 by 2 of 1 plus x into 1 minus x. Now these two cancel. 1 plus x into 1 minus x. 1 by 1 minus x square. So this is the derivative of tan h inverse of x. Okay. So here, you know, tan h inverse of x domain is minus 1 to 1. So in that domain we observed whose graph. This was strictly increases. Hence it is continuous function in its domain. And whose derivative is 1 by 1 minus x square. Okay na students? I hope you have understood this. Okay, right. Now, actually if you want to find whose integration also, okay, so how much do you get? Integration of 1 by, tell me, 1 minus x square dx. Directly you can write tan h inverse of x. Otherwise, 1 by 2 of log 1 plus x by 1 minus x. You can say like this. But your condition for x is minus 1 to 1. X belongs to minus 1 to 1. Okay? Right. Till now we discussed 3 hyperbolic trigonometric functions. What are that? Sin hx, cos hx, tan hx. So sin hx we have defined like this. F of x is equal to sin hx is equal to e power x minus e power minus x by 2. Is this even function? Is this even function? Yes, absolutely. Okay. Even function or odd function? Tell me. It is. Okay, to identify even or odd, what do you have to do? So you have to replace x by minus x. No. Replace x by minus x. Replace x by minus x by 2. Now e power minus x. Minus into minus plus. So here middle minus only. So e power x by 2 you will get. Now from the numerator take minus common. From the numerator what do you do? Take minus common. When you take minus common, your e power x minus e power minus x by 2 you will get. Now what you people have got? F of minus x is equal to minus f of x. Okay. Hence it is an odd function. You know, odd functions are symmetrical about origin. Okay. So you know, even functions are symmetrical about y-axis. But it is an odd function. You might have observed whose graph. This was symmetrical about origin. Okay, right. So if you want to find whose inverse, whose differentiation, what do? Differentiation of sin hx if you want, what do? So derivative of d by dx of e power x minus e power minus x by 2. If you find whose inverse, differentiation e power x minus, so here what do you get, amma? E power minus x minus 1 by 2. E power x derivative e power x only. Here minus is there. E power minus x derivative e power minus x. This is not x. I followed the chain rule. Minus x minus into minus plus e power x plus e power minus x by 2. This is nothing but cos hx. What is the derivative of sin hx? Cos hx. Suppose if you find whose integration, what do you get? Integral of sin hx is nothing but e power x minus e power minus x by 2 dx. So you know the integration of e power x minus e power minus x integration e power minus x by minus 1 by 2. Minus into minus plus. So you will get cos hx only. So integration of sin hx is cos hx you will get. Here derivative of sin hx is cos hx. And if you find whose integration is also, you will get cos hx. Okay? Right. Now let us go to this cos hx. Now, is this cos hx is an even or odd function? Tell me, cos hx, is this even or odd? E power x plus e power minus x by 2. So now put x equal to minus x. If you put x equal to minus x, e power minus x plus minus of minus x by 2. Now simplify. E power minus x, e power x by 2. This is equal to cos hx you will get. Again, same function is repeated. Hence, it is, here what we people have observed, e power, f of minus x equal to f of x. Hence it is an even function. Okay, right. So now find whose differentiation. What do you get? D by dx of cos hx is equal to, so here derivative of e power x only. Derivative of e power minus x. Students, derivative of e power minus x, this is not x, minus 1 you will get by 2. If you simplify, e power x minus e power minus x by 2, so which is equal to, so what you got here? Sin hx you got. Derivative of cos hx is sin hx. Okay? Right. Derivative of cos hx is sin hx. And when you find whose integration? E power x plus e power minus x by 2 dx. If you find whose integration, here e power x integration e power x only. But e power minus x, minus e power x by 2 you will get. This is nothing but what? Sin hx plus c. The differentiation of cos hx is sin hx. And integration of cos hx is also will be sin hx you will get. Okay? Right. I hope you have understood. So in this class, I explained you the domain, ranges, graphs and differentiation, integration of these 3 hyperbolic functions and whose inverse functions, and that remaining hyperbolic functions like cosec hx, secant hx and cot hx and whose inverses and whose domains, ranges, graphs I will teach you in the next class. Thank you.